Hi, dear students. This video record is again about this projection, but here the thing to do is solid model creation. Okay, well, here this pictorial figure we see the geometry of the object. It's a composite right prism. Okay, at this side, well, if we say that this is the front side view, at the frontal side of the object there is a boss. Okay, at the back side one more boss in the same size. Their front views are coinciding, and at the same side, back side, there is one more boss. It is hidden. Okay, well, previous studies, well, in AutoCAD environment, applying classical method, we created this view, drafted this view, and then following studying say in AutoCAD again, using it as 2D facilities, applying the modern method in that case, reach to the same end. And then, well, one more studying might be recorded, but I am going to skip that studying. Say that export the AutoCAD file to Inventor and create the model. This may be such a thing, maybe your home study. Okay, you may study on such a case, because few times I demonstrated how it is done, how an AutoCAD file is important to Inventor and then model is created. You know this. You may study on such an example. But here, this video record, that is the scenario. This is the case. Well, there is no AutoCAD file to import, so need to use the tools of Inventor only. Okay, now let's start. I open Inventor. That is the software. There is nothing yet. Clicked on New File Creation button. And then in this dialog, you know the things to do. Select the unit of measurement. And since it is a single component, not an assembly, make the template selection from here on this option. And then clicked on Create button. Yes, modeling starts from sketching stage, you know. So clicked on Start Sketch button. Select one of the coordinate planes. Well, here in this simulation we have the core regions of the planes defined by a coordinate axis. Select one of them. Not so important you selected this or which one. I'll select the horizontal oriented one. It is my convention. With a click, and then in sketch environment, if there were in the scenario an AutoCAD file to import, then I would click on Insertion button, AutoCAD file insertion. But here in the case, say there is no AutoCAD file to import, so using the tools of Inventor, be able to create the model. For my convenience, I'm going to paste the screenshot on which I have this projection and this pictorial figure, as if I had two monitors. Okay, one part of the screen I'm going to keep the screenshot, the worksheet, and then the other part, well, draw the sketch. Okay, so clicked on image insertion button. This is the button to click to invoke and paste the screenshots or pictures, photographs. Okay, and in this dialog box, show the address. Where is that picture file? I know where it is. It is in this folder. Yes, subfolder, nested subfolder, and here is the picture file. And then say open. And then yes, zoom out. This rectangle corresponds to the frame of that picture. Anchor it arbitrarily with a click. And then press escape button. and if couldn't find the pasted one in the suitable orientation, then using the viewing cube, clicking on the banded arrows, okay, can rotate the sketch plane together with its content and then have the screenshot as it is shown on the worksheet. Okay, then in Inventor, you know, the only method to apply is the modern method. All the tools of Inventor are the tools of modern method. And then, okay, then already studied on this geometry in AutoCAD applying modern method. Life is easier in Inventor, okay? You know the reason why, because it is a new generation software. And for instance, one of the conveniences is that clicked on a certain process button, okay, till you clicked on another one or till you clicked on escape button, that process button will be in its own position. So no need to click on the same button again. Okay, trimming is allowable, applicable in drawing the sketches at any stage. So it's a really an important advantage, okay, in applying the modern method, comparing with the difficulty at the trimming, on the trimming issue in AutoCAD. Okay, well, modern method, you know, first if we have circles for which we know center points, we know size values, then we'll start from circle creation. Okay, how many circles? If it were the case, say environment is AutoCAD and in the end that drawing stage is to have the view, then over there I will create 3 circles. Inner circle, well, for having this visible circle arc indent, a visible circle, and a hidden circle. But here this is the sketch environment, and drawing the sketch we use in Inventor only one line type, continuous thin line. Okay, well, although I know that this is the image of this hidden circle is the image of that hidden feature, so it is hidden. But in Inventor, since the figure will be by definition sketch, the figure to have thereafter to apply the model creation process, well, over there have not 3 circles, 2 circles, okay, not hidden circle, while using the same line type. After creating the model, then if we create the view of the object, then Inventor will create its view accordingly, bringing such a hidden circle. You know this. Okay. Circle creation process. Clicked on this button, and then I'm going to create a circle here arbitrarily, and then one more circle. In Inventor, avoid having dotted lines between cursor and the characteristic points. You know, if exists, then escape from that positioning. Okay. 2 circles. Well, here at a lower level, 2 more circles. Arbitrarily create them. Avoid having dotted lines. And then here, 1 more circle. Okay. And then, well, the rest, co-centricity constraint. Clicked on this button. And then I know that this and that are concentric. This and that are concentric. Okay, and then anchoring stage, dimensional constraint. Clicked on this and then say that from here to there in the horizontal direction, move the cursor and click. Distance is 85. Okay, continue. Clicked. You see this button still in on status, no need to click on it again. See the advantage, and distance is 10 in the vertical direction. Now the center points standing at the correct places with respect to each other. For that one, distance from here to the center of the other in the vertical direction is 50, you know. Yes, now. And distance from here to there is equal to 0. Or from here to there, distance is 85. This is the anchoring stage, and then sizing stage. The diameter of the inner one click is 20. Okay, diameter of the outer one is 40. Yes. Similarly, this is in the size of 40. Indicate this one. It is radius, diameter is 20. Well, here the radius is 10. But you know, in Inventor, if there is a circle, indicate a circle, then Inventor will measure its diameter. So diameter is to be input. 10 times 2, 20. Diameter of the circle is 20. Okay, and then, well, after having the circles, following stage, focus the attention to the boundaries. Okay, these are tangent. I'm going to create this, create that. How? Create a circle. Method is modern at the correct site. Okay, arbitrarily. And then dimensional constraint. Input it is radius. It is radius is 10. But here it is to be written diameter. 10 times 2, 20. Okay. And then in my consideration, this circle is the circle to have after trimming this tangent boundary. Okay, tangents is the constraint. Clicked on this constraining button and then indicate this circle, indicate these are tangent, indicate this, indicate the other tangent. Trimming, yes, in Inventor it is applicable. Clicked on this button and indicate the unnecessary part. Okay, then similarly, create a circle arbitrarily. And then, well, dimensional constraint, it is radius 40, this one, and diameter dismiss is 80. Here, I created this circle, but at this stage, I see that this circle relative to the available ones is at the wrong side. Well, because, you know, on the projection, center of this, center of the others are both at the inside, but here I have the circles at the outside. So, well, to be able to have the circle arc at the correct side indent, I need to bring this circle to the correct side relatively. Applying move process, I clicked on and indicate selection button in the dialog box you see is on. This is the stage to indicate the entity, which is the entity to move with a click, and then clicked on base point indication button. Which point is base point? Which one you like for this ordinary moving process, move process, within the area bounded by a circle, indicate center or indicate another point with a click. It is to take a right to move the circle. Move the circle to the suitable side, the correct side is positioning, well, such that the centers of the available circles ought to be at the correct side. And then with a click, anchor it and clicked on done button, finish the move process, and then apply tangency constraint. Clicked on this, indicate this circle, indicate that these are tangent, indicate this, indicate other tangent, and then trimming, yes, why not, apply. Yes, and then can trim this portion. And then yes, the rest, well, there is one more circle arc here to have. Okay, you know how it is created. Apply the process, circle creation process, arbitrarily create the circle. Dimensional constraint, well, 95 is the radius. Diameter, clicked into this box, test whether simple arithmetic is acceptable. 2 times 95. Instead of in mind performing such a multiplication, just write the expression into this box. Asterisks in Inventor means multiplication operator. And then say OK. Yes. After setting the size of the circle, then check whether the centers of the available ones are at the correct side. Otherwise, apply move process for the for bringing the circle to the correct side. Now here in my case, no need to apply move process because it is at the correct side. Okay, just can apply, upload the constraint, tangency constraint. This circle indicate, that circle indicate tangent, this circle, that circle tangent, and then the rest trimming. Yes. And then you have the time to deal with these straight lines. Okay. Since I need to have a horizontal reference in the order, I'm going to create this line first and then the inclined line. Okay, you know how. Create the line arbitrarily first, locating its terminal point at the correct side. How many millimeters? More than its order of magnitude. In doing this, avoid having dotted lines between the cursor and the line. Cursor and the characteristic points of the already created ones. Okay. If you have a dotted line between cursor and a certain characteristic point, escape from that positioning, little bit moving the cursor. Okay, and then, well, I know that this line is horizontal. That line to have this boundary indent. Input the constraint, horizontality constraint, clicked on this and then apply, indicating the line. Now it is perfect horizontal. And bring this terminal point to the correct location, for which the coordinates 30 by 25. Dimensional constraint from the circle. If you indicate center, yes, or if you indicate circle at any point, Inventor will attempt to measure the diameter, but if you indicate one more point, then Inventor can understand that your purpose is to input dimensional constraint for locating the entity. Okay, while in this direction, move the cursor and clicked, and into this monitor box, write the constraint. In the vertical direction, the coordinate of the point is 25. And then, while indicate the circle, indicate the terminal point of this line. In the horizontal direction, it is coordinate is 30 relative to the center of the circle, those circles. Okay, then the line is in the correct inclination and its terminal point is at the correct place. And then can create the other line. First create the line arbitrarily at the correct side where we're gonna have the tangent line, okay, at the same side. Create it longer than its order of magnitude. Press escape button and then the constraints. Dimensional constraint. Indicate this line, indicate the other line. Now Inventor understood that the purpose is to inputting the inclination angle. Move the cursor in this direction to have the angle as measured in the same sense as it is shown on the projection, and then into this box write the correct value, 60. Okay, and then, well, or first make the line tangent and then input angle, or vice versa. Order is not important here. Tangency constraint, indicate the circle, indicate the line. Yes, it is tangent. And then trimming, yes, it is applicable at an intermediate stage. Click on trim button and then indicate the unnecessary parts. And this part of the line as well. Yes, and then the last entity to add to this sketch is this boundary. Okay, in applying to create such a circle, it has only one tangent point. Well, in applying the modern method, the first thing to do is that create a circle arbitrarily, and then input it as dimensional constraint. Diameter is 40. and then upload it as characteristics. If the software were AutoCAD, inputting the coincident constraint, clicked on this button. Before indicating the circle, I would click on down direction key of the keyboard and selected from the list object option. It is a must to say that not the center of the circle, but a point along the circle is to be coincided with the other, onto the other. In AutoCAD there is such a trick, but in Inventor, if you indicate center, then Inventor will understand that that point is the point to coincide. If you indicate a circle at any point along the circle in the vicinity, move the cursor to the vicinity, and after seeing this color changing, make a click. Then any point along the circle will be coincided with the other. There is no trick in Inventor. Yes, do it. Indicate the circle, indicate the terminal point. Yes, it is passing through that point. The other characteristic, tangency. Clicked on this, indicate the circle, indicate the other. And then trim the unnecessary part. Yes, repeat again. Although on this figure, it is the view of that object. This circle is hidden in dash form, but here this is not a view. This is not the view of the object. It is the necessary profile. It is the necessary sketch. So in sketch mode, have only one line type, continuous thin. Okay, this is the line to have the necessary profile to extrude the material. So do not attempt to draw this line or try to have this line is dotted one in dash form. Don't forget, this is not the view, it is the sketch. Okay, finish the sketching stage. Clicking on finish sketch button, and then the rest extrusion. Well, here, have a look at this pictorial figure. The thickness of the main part is 10. Okay, here there is a boss, its thickness is 10. Okay, I know that the other boss is also in the same thickness, 10. The thickness of this part is 20. 20 minus 10, this means the length of the other boss is 10. Okay, knowing such values, apply the extrusion process. It's a right prism, so the correct process to apply extrusion. Okay, I'm going to create the main part first via indicating this area, this annulus, that annulus, and this one. Okay, thickness is 10. Yes, clicked on apply. And then, well, for creating the boss at the frontal side, indicate this area. I know Inventor will offer cutting process. No, clicked on this button, say that add. At the back side, relative to at the back side, there is a boss. Here it is partially available pictorial figure, and it is at the back side, and its length is 10. Relative to the plane where I have the sketch, yes, the tip surface 10 millimeters away. So this extrusion value is correct. Clicked on apply. Yes, there is one more boss. Indicate the same profile. Say that not cutting but material adding. Check the direction of the extrusion. Yes, it is to be in this sense. It is correct. Well, the surface of this boss, flat surface of this boss, relative to the sketch plane, relative to the plane on which I have the sketch is on this surface, I know. It is 10 plus 10, 20 units away. So into this box write 20. Yes, now the frontal boss ready to be created. Clicked on apply. Yes, created this boss. And then at the back side there is one more boss. Well, the necessary profile is over here. Indicate the profile. Inventor offering cutting. No, not cutting but adding. Check the direction. If direction were wrong, then I would click on this button to reverse the direction. But here the direction is correct. Well, the length of this boss relative to the plane on which I have the sketch is 10. And then, well, I applied all the processes for creating all the features. I think it is done. There is no more feature to create. So clicked on OK button. And then yes, after using a sketch and clicking on OK button, the sketch will disappear from the screen. In sketch environment, I have screenshot. I use that screenshot for my convenience, but thereafter there is no need to keep it in sketch plane. So, well, I'm going to ask the visibility of the sketch. Well, whenever you need to use the same sketch for drawing purpose or for deleting something, for editing something, then bring the cursor to the browser. Over there, find the sketch icon. Yes, right click the mouse and then ask it as visibility. Right click and in this list find visibility option and with a click make the sketch one more time visible in the screen. And then it can be used. But here I ask it as visibility just to delete this picture. With a click indicated. Okay, and then sorry. Well, I made it visible, but need to turn back to that sketching stage. How? Right click and then edit sketch. In edit mode, yes. Indicate this picture, clicked on delete button. And then finish that sketching stage and then hide the sketch. I use the sketch and then finish all the things. After creating the model, of course, keeping the sketch in the screen as visible is a poor practice. Good practice is that bring the cursor onto the sketch icon, it corresponds to the sketch. Right click the mouse and deselect visibility option. Make it invisible. Take it as visibility. Okay. Here is the model of the object. Say it is made of which material? Well, it looks like gold, but say it is not gold. Otherwise, it would be extremely expensive object. Let's say it is made of brass, soft yellow brass. Right click the mouse, assign. Close the dialog box. Okay. I'm going to, since this pictorial figure is in this orientation, okay, then I'm going to use this orientation, define this orientation as the home positioning. So using orbit facility, clicked on this and then rotated it. Yes, use orbit facility to allow the other person to see the object, the model of the object from any direction, in any direction. And then if you say that, yeah, well, when you clicked on cutter symbol, you want to see the model as oriented like this, then, well, after positioning it like that using orbit facility, okay, bring the cursor on the cutter symbol, right click the mouse and say home positioning. Set current orientation as the home positioning. That positioning as the home positioning for this model. Selecting here fit to monitor option. Although it is written view, this is not a view, you know, this is the display of my computer, fit to display, fit to screen. Okay, and then, you know, zoom out or zoom in, zoom in. Whenever you clicked on cutter symbol, then you find the model as you determine it in that orientation. Okay, I'm going to save the file. By the way, I forgot to save the file. Save as. In sketch mode, cannot save file. Finish the sketch. Clicked on finish sketch button. Okay, and then pass through the saving stage. And then be able to turn back to the same sketching stage. Bring the cursor to the browser, find the sketch icon, right click and select edit sketch option. You know, all of such things. Okay. And then show the address for this model. I know which folder is the address in my computer. Then generate the name for this file, surname, ID number, and then this is the studying from worksheet 10. It is identification. The view has been identified saying 6th view, view 6, V6. Okay, here I'm going to say that I created this model only using Inventor. Only, I wrote this word, Inventor. Okay, I didn't export or import AutoCAD file. Using the sketching tools of Inventor, had the sketch and then apply the model creation process. Created the model using the tools of Inventor. Only using the tools of Inventor reach to the end. Okay. Clicked on in this regard, say only Inventor. Date of the creation. Today is the 17th of April. April 17. Okay. How about the view? Say that after having this solid model of the object, whenever someone asks the orthographic projection, then Inventor is quite powerful on view creation, you know. Clicked on new file icon and then select the quadrant. Metric means you selected first quadrant. English means you selected third quadrant. You know this. First quadrant projection. Obey to the rules of ISO. Have the drawing file in Inventor format. In short, this means select this template option. ISO.idw. Clicked on create button. And then, you know, have a paper simulation. It is in A3 size. Clicked on base view creation button. And then at that stage, well, clicked on cutter symbol first to allow yourself to see the simulation as you fixed in model environment in home positioning. And then much more easily you can understand which side is front side, and so need to direct which side parallel to the paper, surface of the paper. This is the front side, and this surface of the viewing cube is parallel to that side. So if I clicked on the surface of the cube, I know can direct the projection, can direct the model at the background such that it is frontal side going to be parallel to the drawing paper, surface of the paper. So can say that it is the front view. Scale, if you're going to create only one view, yes, scale can be 1:1 or even more. But if you're going to create other side views, then yes, you may use a different scale factor. Here, I'm going to create the front view here. And then, since it is a composite prism, one view is not sufficient. Create the, for describing the geometry, create the left side view as well, or top side view. Two views are needed. Show this. Okay. But if the left side view won't be understandable, okay, because you see here the boss at the back side and the other boss are in alignment, almost alignment, so that view may not be understandable. So well, create the top side view as well. From the top view, reader can see that here and there are two identical bosses, and at the back side there is one more boss. So good idea. For the convenience of the reader, create three views. So since there will be three views on the paper, scale factor relative to the size of working area, suitable scale factor I see from this simulation, 1 to 1. The first style button must be on to enable the software to create not only the images of visible features but also the views of hidden features, and then say OK. And then yes, you see here on the projection, although we drafted this circle in sketch mode using a continuous thin line, but you see Inventor created the image of the boss using dash line. Now this is the view of the object, but in sketch mode, well, here that is the model, and here in this sketch mode, edit sketch, turn back, that circle is the necessary boundary to have the profile. It is not view. This is not the view of the object. This is the necessary profile. This is the necessary sketch. Okay, but here this is the view. Okay, now if there are three views, then you know format requirement, try to balance them. Well, the space between them, it is needed to show the dimensions here and there should be in the same order. Distance from the tip point of the front view to the upper margin, and from the tip point of the top view and the lower margin, those distances should be equal. From this limiting point to the left margin distance, from this outmost boundary to the right margin distance should be in the same order. It is a format requirement. Okay, and then axis indication, annotation, center cross, indicate this outer circle, indicate this one, yes, symmetry axis, on the front view, these are okay. How about the longitudinal axis? On the top view, to say that this rectangle is the image of a revolved feature, there is a hole over here, it's a revolved feature, indicate the surface limit lines, okay, and between them program will create the axis of symmetry. Well, here there is a notice, I don't know why Inventor noticed me. Clicked on this, indicate this limiting line, indicate that limiting line. Well, program noticing me, why in solid model environment, is there any problem? Save the file one more time. I save it. Okay, and then, well, longitudinal axis on this view, clicked, and then create the symmetry axis. Well, here Inventor noticing me that there is a problem. I think Windows Explorer has stopped, so couldn't convert, Windows couldn't convert the corresponding code to machine code, because while indicating this and that at the background, the high level language using, well, we have generated a code, and thanks to the interpretation of that code, the process is realized. Here I think it has stopped, so well, couldn't indicate the axis of symmetries. After finishing this video record, I'm going to restart Windows Explorer, and then without any difficulty can indicate the longitudinal axis here, and on the left side view as well. Longitudinal axis, clicked on this button, and then, well, I see that this is the limit of the hole, it is over here, and this is the other limit indicate, and between them have the longitudinal axis. But the same conversion problem exists. So well, I'm going to stop the video record at this stage, and then yes, I think it is clear. That is the set of views for this object. Okay, finish the studying. You see, only applying all the things only by using the tools of Inventor, we managed to create the model and also the required orthographic views. Okay, then, my dear students, ending the record. Stay healthy. Bye bye.